So friends, we'll be doing a lot many experiments, but we'll start with an experiment which is actually more fun. We call it lava lamp. So Hitesh, so Vikas will just spotlight this one. So Hitesh has a beaker in which he's putting some water, and we are putting a layer of refined oil on top of it. Yeah, I think that should be fine. And now what we will do is, this is a very easy experiment. You can do it easily at home later. So now we will sprinkle some salt over the layer of oil. And I would request Hitesh to, if possible, show it through the smaller camera. I mean, bring the camera close by so that the audience can see. It's very clearly visible even now. So everyone is expected to observe carefully what they see and what are their observations. Then you can write on the chat box. What is it that you see? Something has started happening. Please write what you are seeing. That request is especially to children who are observing. Pratham Mittal is saying filtered bubbles. Junaid has asked, is it ice? No, what we are putting in is salt. Actually, from the top, we are sprinkling salt. So Garima is saying salt is not dissolving in water. Garima, right now you have to say what is it that you are observing. So Shivangi is saying the salt forms clumps and is deposited at the bottom of the beaker instead of dissolving in water. So Shivangi, the salt is forming clumps with what? Salt is making bubble formation. Yeah, so some kind of bubbles are forming. So what is it that is going down? It is definitely, it has some salt, but does it have anything else? I mean, can you guess? Okay, so Vedant is saying oil and salt. And Shivangi is saying oil. So yeah, oil and salt seem to be going down. And what is it that is coming up? See, something is constantly coming up also, though at a slower rate, but something is coming up. Air. Preeti is saying air. Preeti, observe that there is no air between the layer of oil and water. So something is happening between these two layers, and there isn't any air. So try to make some guess about what could be the bubbles which are coming up. So two people are saying the oil is coming up. Pratham Mittal saying, is it hydrogen? Pratham, there is no source of hydrogen here. See, water doesn't normally give its hydrogen, will not break up into hydrogen easily. So there is no source of hydrogen here. Okay, so VG Varshit has said the oil is less denser, therefore floating. Salt going deeper from the first layer, oil makes salt non-soluble. And somebody has said it was oily bubbles. So, okay, then someone said because the oil is dense, there is a layer of oil on salt. Okay, friends, so the thing is, yeah, so I mean, you can actually observe a little more, but right now we think that right now as the salt is heavier than water, so and oil. So the salt tries going down, and when it tries going down, it actually makes a blob. It makes a blob with oil. So salt and oil make a blob and go down. They must be heavy to go down. But as it goes down, comes down, the salt dissolves and only pure oil comes up. That difference is very clearly visible. What is coming out up is pure oil. It doesn't have salt around it, but what is going down has salt. So if you see carefully, so the thing is, this experiment is interesting because it has, we can very clearly see the same thing first sinking and then in some different form floating. So what causes floating and sinking is the question we are going to be exploring throughout this session. What are the reasons behind floating and sinking? So this experiment is just to start thinking in that direction. Of course, we'll do many other experiments as well. So now I will request Hitesh. So we'll now take a water bucket, a transparent water bucket. And we have a lot of stuff here. We have vegetables and fruits and some assorted items. And we'll show them to you, ask you, you have to predict for every single thing that we have. You have to predict whether it will float or sink. And then first you have to say it on the chat whether it will float or sink. And then we'll show you. We'll drop it in water and we will see whether it floats or sinks. I think that's fine. The bottom should also be a little visible. Yeah, this is fine. Okay, so friends, we are starting. So Hitesh is starting with, Hitesh, show the thing. He's starting with a block of wood. Okay, so float or sink, what do you think? When we put it in water, what will happen? Okay, people are saying float. So everyone is saying float. You are right, absolutely, it floats. Okay, so easier for wood. We have seen huge logs of wood float also. Now here is a steel or some kind of iron object, which is rather heavy. So will it float or sink? So everyone says it will sink. So fine, we put it and there it goes. Yeah, so, okay. Now let's come to some things which are not so easy to predict. Now, okay, Hitesh has started with a story. Okay, go ahead. What do you, okay, wait, sink or float? Float. Okay, sure, put. So floating. Okay, Aditya said sink. Okay, let's see more. Potato, no, okay. This is walnut, akhrot. Float or sink? Float, okay. Somebody saying sink, okay. Float, okay. So, an apple, float or sink? Half the people say sink, half the people say float. So let's see. Floats. So you know, in a college once we were doing this, and people actually explored the question: what will happen if we drill a hole through the apple? Will it still float? So what do you think? If we drill a hole through this apple, will it still float or will it sink? We can do it actually, though we'll need to bring a knife or something. We can do, but what do you think if we drill a hole? So people are thinking it will sink. So this one, apple. Okay, we'll do this experiment. We will have to make a hole somehow using a knife or something. Anyway, how about this rubber thing? It's a rubber block. I mean, actually, it's a table leg, stand of a leg, table leg. So, okay, so people are saying this will float. Somebody saying, some people are saying sink. So, okay, so drop, sank. So, okay, not everything is so easy to predict. Anyway, carry on. Hitesh, something else. We still have to do the apple experiment. This is a hard rubber ball. I mean, solid. There's no, it's not hollow. How about this one? Sink or float? People are saying float. Somebody is saying sink. Okay, float or sink. Sink. Sank. So the two rubber items we have put have so far sank. Okay, let's see more. This, okay. How about an orange? Orange, people are saying will float. Okay. Okay, okay. So you are right. It floats. What if we peel the orange then? So Hitesh is actually peeling it. So VG Vashisht is saying that it will sink. Others, Abhay Rana is saying it will float. Jatin Patel saying, let's see. As they say in English, the taste of pudding lies in eating. So, okay, put inside. Junaid Alam says it looks delicious. Anyway, it sank. Now show the other one. I mean, put another orange with its peel. So let's put this also and see. So this isn't it surprising? I mean, the orange, when it has its peel outside, it floats, but when you peel it, it sinks. Delicious is fine, but it's behaving a little funny, isn't it? I mean, behaving strange. Why should it sink after peeling? Okay. So that's the exact question we want to explore through this exercise. Do we have other things? We still have. Okay. So Sachudan is saying that air inside it matters. We'll see what matters. We'll come to that question. I mean, of course, you are free to make guesses. You can make guesses and suggestions, and of course, tell us the principle. Okay. So here's a carrot. People are saying it will sink. So Hitesh, let's see. Oh, people already predicted, but it didn't really sink. Do you see? It's floating on nearly on top. It didn't actually sink. Almost floating. Well, okay. So now we have this stupid plastic piece, which has a hole inside. What do you think? What will happen to this plastic? So one person said sink. 2, 3. Okay. Many people are saying sink. Many people are saying float. So here opinion is clearly divided. Sink. It looks very light. It actually is very light. Still it sinks. Okay. So here we have a hard rubber ball, what we call as crazy ball. How about this one, Deepak? How about this one? Float, sink. So again, divided opinions. So please put. Down it goes. And now we have two light, one is a thermocol ball and one is a light rubber ball. This rubber ball is pretty light in weight and also, I mean, it's like spongy. So let's see. People are saying float. Float for both? Somebody said float, float. Okay. So let's see. Float, float. Yes, float, float. And in fact, if you try pushing them down, they don't even go down. They stay up and they are as if very eager to stay up. So, okay. So is there any other thing? We had that, we have that cup, no, that crucible, chemistry crucible. Yeah, so there is this cup kind of thing made out of your china clay, ceramic. Yeah, ceramic. So people are saying it will sink. Abhay Rana is saying this will float.
What do you want me to do? Sink or float?
See, Hitesh Bhaiya is clever. He can make things sink or float. He has magic in his hands. You tell him what to do, what, and he'll do that. It's floating. And now, now Hitesh, will you make it sink? Okay. Right. So, so friends, actually floating, sinking behavior. Do you have other things? Anything else? Potato? I forgot to bring ginger. But what do you think ginger will do? So we have potato and lemon. How about lemon? Rupee sink. Lemon float. Okay. There. Goes. How about potato? Sink. Okay. This should be easy. Shimla mirch, capsicum, float. Okay. Put. Right. So I think we are done with materials. Oh, we have tomato and we have this arbi. What do we call arbi in English? I don't know. So people are saying float. So put. Goes. Arbi is what in English? I have no idea. Okay, tomato. Tomato, people are saying sink. Some are saying float. Okay, put. Comes up. So we are nearly done, right? So let's move on. So friends, actually, okay, so Varshita is saying, as the skin of the orange has molecules of air which makes them float. Varshita, this is the question we are going to actually explore through the session. So, so we will now, we will see our, I'm just sharing, just a sec. Achha, Vikas is sharing. Vikas, you are sharing the PPT?
Right now, you are sharing.
Okay, so okay, I'll share then. Wait. Oh, wait. So okay, so I'm just sharing our screens. So here's the sponsorship by NCSTC. Then we saw the lava lamp, and then we did the floating and sinking exercise where orange was the funniest. When you peel, it will sink. Unpeeled, it will float. Junaid Alam is asking, is the water cold? Yes, it's ordinary tap water. Nothing much colder. So, okay. Now what we are going to do is, we are making some statements here. The statement is written below in dark. And you have to say on the chat whether you agree with this statement or disagree. You can say yes or no, right? So we are asking, lighter objects float. You can just say yes or no. Some people are saying no. Somebody saying maybe yes. Yes, no. So no single opinion. But we see that at times we see light objects floating, but which is also true. Like you saw the thermocol ball floating, but this plastic piece seems very light, but it actually sank. Souvit is asking, float where? Float in water. So Parth Verma is saying it depends on the situation. So Parth Verma, in our real life, we have millions of situations. So can we keep deciding on every situation what makes things float or sink? See, it's a complex question. It's a difficult question to actually decipher. So let's explore it. It's in our real life also. It matters. You know, sometimes people can actually float on water. They can swim, but in other cases, people actually drown. So it's also a matter which decides our life as well. So we'll find the principle. We find the reason why this happens. So, is there any rule to sinking and floating? Is that's what we want to build? So okay, lighter objects may float but may also sink. So this is definitely not true. This sentence. So here's the opposite one. Heavier objects sink. Do you agree with this one? Yes or no? No. No. Here also another no. No, 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 no. Everyone is saying no. But we had that heavy steel thing, no? It actually did sink, that iron object. The iron object actually sank. And if you take if you take a stone, we have a stone piece. So if here's a stone piece, so if we put it in water, what happens? It sinks. Let's see. It sinks. So Pavan Goda has also
Anjumala,
said.
we cannot see the screen because you are sharing right now.
Oh, sorry. So okay. So I have to stop share. Okay. See, here's the stone. So sinks, right? So heavier objects do sink in a lot many cases, but as somebody has said, warships float, any ship floats. I mean, and ships are very, very heavy, thousands of tons at times, but they float. So, okay, it doesn't seem to have everything to do with heaviness or lightness, but it has something to do with heaviness and lightness. Now that's strange. And so let's see more statements. So comes the next statement. Shape decides floating. Does shape decide floating? Yes or no? So 2 people said yes. 2 people said no. 3, 4. Somebody said maybe. Yes, in some cases. No. Okay. So we can show you that shape has something to do with floating. So we will for floating and sinking, we can show a bowl, steel bowl and a steel katori, steel bowl and take a spoon, steel bowl and steel spoon. So both objects are made of steel, and if we put them in water, one floats and one sinks. So is the shape deciding floating, sinking? What do you think? Shape is deciding sinking, floating? People are saying yes. Now we will show the same shape, one thing sinking and one thing floating. So we will take a steel spoon and a wooden spoon. So steel spoon and wooden spoon. And now we will put them both. So Parth Verma is saying density maybe. Varshita is saying we can make even a bowl sink. So that's what we are trying to find out. So shape is not the only thing which is deciding sinking, floating. So let's see what does decide sinking, floating. What about size? Does size decide floating? I mean, as in smaller objects floating and bigger objects sinking. Does size decide floating? Okay, many people are saying no. We did not see any difference with size. So how about material? Does material decide floating? So people are saying yes, material is deciding floating. So now we'll show you. We have okay. So we have aluminum foil for which we have made a loose ball, and then we have aluminum foil for which we have made a very tight ball. And we have actually hammered the other one so that it's become very tight, and now put both. There goes the tight one, and here floats the loose one. So people have started coming with density and volume. Yes, friends, we'll come to all of this very soon. Clearly, material is not the only thing deciding sinking, floating. Junaid Alam is saying, Junaid Alam, you were there in class day before yesterday, so I will request you to please keep quiet. Parth Verma is saying airspace is there. Parth, we'll see what is there. Yes, we'll come to the reasons. This is okay. How about depth of water deciding floating? I mean, do you think that some things will drown in a river, but will not drown in a tub? Or some things which will float in a river will also float in a tub? Do you think so? Actually, वो बड़ा वही ले लो. I mean, नहीं, हितेश, बड़ा वही ले लो. So Hitesh has one tall container and one short container. So the depth has changed, and he will put the same object in both. So you have to take two same objects. Take something that will float in one. Oh, so he has taken two walnuts, akroot. So put in both. Doesn't seem to make any difference. The depth of water doesn't seem to make any difference. We still have that apple to, okay. Okay. Sink, he's putting one marble in one of them. So it sank here, and in the other one also it sank. So sinking, floating doesn't seem to do anything with the depth of water. We still need to do that apple experiment. So while Hitesh is making his hole in the apple, till then we will carry on with some discussion. So friends, so as this girl on the screen is wondering, is there no simple rule to floating and sinking? Is it? I mean, it seems like a detective story, you know, any clue you have, that clue seems to go wrong somewhere or the other. So you think, like in a detective story, the detective thinks this person is the murderer, that person is the murderer, but every time something else happens, and some other clue is there which doesn't let the detective decide. So this seems like a mystery story. So Jolly Jane has said, the plate spoon will float, the steel spoon will sink, the wooden spoon will sink. See, at least steel and wooden spoon we showed floating, steel spoon we showed sinking. Plate spoon, probably you mean the ceramic spoon. We don't have one right now. So Varshita is saying, well, there is a rule, and that rule is density. Okay, so thanks for giving us a hint on which we will proceed till Hitesh manages to make a hole through the apple. So we will proceed with density, and then we'll come to the apple back again. So first we need to revise what is density. Some of you must be already familiar, but some may not be. So firstly, we'll take the formal definition, which is mass. Now, what is mass? Mass is the amount of substance, amount of material in something. So if I say this thing, its mass is the amount of plastic which is there, plastic or whatever is inside. the amount of material which is there, amount of substance inside. That is, so we divide, whenever we divide mass with the volume of that same object, the space that object is occupying, we get density. This is the formal definition, and we say, oh, sorry. Wait. What happened? And the units would be, if you measure mass in kilogram, then it will be kilogram per cubic meter or kg per meter cube. Or if you measure mass in grams, then it will be gram per cubic centimeter. We can write it as gram per centimeter cube or gram per cc, same thing. Or cc is also same as actually milliliter, so we can also write as gram per milliliter. So units, of course, are our choice, but let's try understanding what this definition actually is telling us. So okay, here I have also tried to differentiate between mass and weight, because at times many people are confused between these two. So mass is always measured in kilogram or gram. Mass is the quantity of substance, and weight is actually the pull of gravity, which is mass times g. This quantity g, which we call as acceleration due to gravity. Again, some of you may be familiar, some of you are not familiar. It's like when you are measuring in kg, it is 9.8, but when you are measuring in gram, it becomes 980. So mass, when multiplied with some constant value, actually gives us weight. But weight is actually a force, so measured in newtons. But normally in daily life, or often, people measure weight. When you go to the market to buy potatoes, often using some kind of balance, weight is being measured, but they tell you the mass in kilograms or grams. So because there's just a difference of a constant, this difference is just of a constant, we can like remove that constant or assume that constant, and just people measure the weight, because it's actually possible to measure weight very easily. Even when we put something on my hand, I sense its weight. But what we measure, what we are specifying or saying is often mass in kg. When we are saying kg, we mean mass. Kg or gram is actually mass. But right now, since the session is on density, so let me come to the notion of density. Okay, so friends, you're seeing two forests on the screen. So on the left-hand side, you have a lot many trees, and then right-hand side, few trees. So which forest will you call dense? Left side, right? So we call such a forest dense, which has lot many trees and plants. We say it's a dense forest. In Hindi, we say ghana. So the word density and ghanatva have an origin in this word, the way we talk about dense forest and all that. But here the forest has an area. It's a flat land over which you have plants. But when we are talking about density, we are talking about a volume. We are talking about the three-dimensional space something is occupying. So this box, okay, I'll have to stop share. This box is occupying a three-dimensional space. It's not a flat thing. It's not a two-dimensional area. It's a volume. So for density, we say it's mass upon volume. So firstly, we are seeing what is inside this volume in this 3D space. Nandini Sand is asking, okay. Oh, she made a comment. Okay. So, so when we say we are talking about density, so firstly, we are talking about the space, the 3D space, the volume. And in that, in the volume, what we are trying to see is what you can see written on the slide. In simple words, it is how much mass is filled in every unit of that volume. If you choose a unit volume, I mean a small volume, either it's centimeter cube or you call it milliliter. Centimeter cube is roughly this much. I don't have something of exactly a centimeter cube, but anyway, it would be a small volume. Or if you take a meter cube would be large, a large cube of meter by meter side. So when we are saying in that every unit of volume of that thing, if you are talking about this thing, so every unit volume, how much mass is filled there in every unit volume? How is mass distributed throughout the volume, throughout the space? How is it distributed in every small volume? Or rather, you are talking about the denseness of that object, whether it has more mass filled in every small volume, small parts of that volume, more mass filled or less mass filled. How much mass is filled per unit volume, every small part of that volume. I mean, we have, okay, let me first try showing it, try to show you this Rubik's Cube. Rubik's Cube is like, you can see that it's a stack of small cubes. It's built like a stack of small cubes. So when we say, so the total volume here would be, I mean, each of these, if you imagine each small volume, if you imagine it to be each small one, if you imagine it to be a unit volume, suppose you say this is 1 centimeter cube, 1 cc, then we have like 27 of them, like 3 by 3 by 3. Or rather, if you see on the top layer, there are 9, then there will be a layer below again having 9, a layer below having 9. So 27 of these small volumes, small unit volumes. And suppose the total weight is 54 grams of this total big Rubik's Cube, then the density would be 54 divided by 27 or 2 grams per cc, which means you are saying that the distribution of mass here, distribution of substance here is in every small volume, there is 2 grams filled in. 2 grams is distributed there. So whether you take a small part of this cube, you cut off this part or that part, any part, the distribution is the same. I mean, if you take a small unit, it has 2 grams. If you take double of that, the mass becomes double, but also the volume becomes double. If you take 3 of these, the mass becomes 2 plus 2 plus 2, that is 6, but the volume becomes also 3. So the density still remains 2 grams per cc. So if mass keeps increasing, so does the volume. So the distribution of mass, or rather density, remains 2 gram per cc. Does this thing make sense, what I'm saying? This idea that density remains constant, even if the thing becomes larger or smaller, does it become clear? Vedant and Parth have said that they have understood, but are there other people who have not understood currently? So Manan Agrawal is saying, I should summarize again. So Manan Agrawal, what I'm trying to say is, I'm saying that for finding out density, I'm trying to find out that how much mass is filled inside every small unit volume, right? Unit volume means every small portion of chosen volume. I mean, we have chosen a small portion. So suppose in a Rubik's Cube, this is the small portion. This is 1 unit volume. So this total cube is made out of 27 such units. Can you make out? If you count them all, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 on the top layer, then there is the lower layer not fully visible, but it will again have 9, Then the third layer below, it will again have 9. So there's 27. So the total volume is 27 and total weight, mass rather, total mass is suppose 54. I've taken just a convenient figure. So the density comes out to be 54 grams divided by 27 units, and which comes as 2 grams per centimeter cube, which means that every small unit of volume here, every small, whichever one you take, it has 2 grams inside it. Whether you take this unit or this unit or this unit, each of them have 2 grams. So whether if you take like a greater number, suppose I take 4 of them here. So if you try finding density, so the total mass will be 2 plus 2 plus 2 plus 2, mass will be 8, but volume will also become 4, 1, 2, 3, 4, 4 units. So the density will still remain 2. So whether you take a bigger portion or a smaller portion, the density doesn't change. That's what I'm trying to say. Because it's distribution of mass, the distribution or denseness of this material does not change. The same question has been explored here. So do you think if you have a large potato, suppose half a potato or a small potato, or you have potato slices, will they have same density, or this one will have lesser density and this one will have more density, or vice versa? How will density change from this one to this one? What do you think? So same density. Yes, as many of you have said, it will be same density actually. Density doesn't change if the material comes into a very large chunk or a very small chunk. I mean, the same idea we have placed here also. Okay, but when you compare the two things of the same mass, same volume. Suppose you take a potato, which is potato and a stone. Both have, suppose, same volume. Suppose you measure the volume and determine the same volume. Which will have greater density? The stone will have greater density. I mean, because if you having the same volume, if you measure the mass, the stone has greater mass. So its density is same, but even if you were to take a smaller potato or a potato slice, or even if you were, instead of a stone, you took a full mountain, even the density of the mountain, the density of the stone will remain the same as long as the material is evenly distributed. So Dr. Prem Sharma has raised hands. Do you want to ask anything? If you want to ask, Parth Verma is saying the voice is lagging. Does everyone have a problem?
No problem.
Okay. So then Parth, you'll have to check your device, this is volume setting of your device. And if voice is cracking, you may want to check your internet connection, because often these are problems of the internet. I mean, none of us are saved from this. So friends, the stone density will be larger, even if the stone is bigger or smaller, and even if it's not the same size as the potato, its density would be larger. So what can you say about the density of a needle, a steel block, and a steel spoon? So 3 of you have said density is same, 4th, 5th, 5 of you, 6th. So many of you are saying the density will be the same. this is actually a slightly difficult idea to capture because I mean, it appears as if smaller things will have less density, but it's not so. As long as the material is same and it's evenly distributed, the density would remain the same. So, once we have decided on density, let's come to something that we call as relative density. Water has been taken as a standard for our calculations. I mean, scientists have deliberately done it. So, I mean, when they decided on how big a centimeter would be and how big a gram would be, they took it in such a manner. They chose these units in such a manner so that the water has a density of 1 gram per cc. So that water acts as a standard for everything else, because water is everywhere on our planet, and so often we need to compare things with the density of water. So therefore, water is taken as one, the standard, and we compare everything else's density with water density of water. So what we call as relative density is ratio of density of a substance to density of water, which is simply the density of that substance divided by the density of water. For example, steel has a density of 7. So its density is 7 times water. So we say its relative density is 7. Relative density is just a ratio. It will not have units. So right now, what we are going to do is, we are going to actually, on our table, we are going to take, you can see Hitesh's screen, on which we are going to take oil, refined oil, then water, and then salt water. Taking the same volume of all three, 100 ml, we will weigh them. We will weigh them. Just a sec, there is a question. Will density of water will change with temperature? What do you think, Vedant? Will it change? Yeah, so you are right. Actually, we know that materials expand on heating. So with temperature, materials expand, so that the density changes a little, becomes less. Though the difference is very, very slight. Okay, so Hitesh is going to do these 3 measurements. Dr. Prem Sharma is asking me to repeat the question. Actually, a question was asked by Vedant Sakre. He asked that will density of water change with temperature? And he himself said that it should decrease with temperature. So we have a digital balance on which we will just measure the weights of all the 3. I mean, it reads in grams that directly give you mass. Though we have not measured the mass of these beakers, so this is just for comparison's sake, just seeing how the 3 things compare. So Hitesh will tell you the readings, or if you can show to the audience, that will be great.
Because could you switch to my other camera?
So we are seeing it in reverse. Yeah, this is 206.5, is it?
Yes.
So 206 grams. This is the density of. I mean, this is the mass of what? Tap water.
Yeah.
Okay, so for tap water, we are seeing 206.5. Then salt water, we are seeing 216.4 as far as I can see. And for oil, we are seeing 195.9. So oil was 195, water was 206, and salt water was 216. So which do you think is the least density? Which has the least density? Which has the maximum density? Oil has least or maximum? Least oil, and maximum density is salt water. Right. That's what, yeah, everyone is saying salt water has maximum. And so you see.
Maybe we can ask, how do you know?
Okay.
What makes you say?
Yeah. How did you decide? Friends, how did you decide? So Vedant Sakre has said the same volume, oil has least mass and density equal to mass upon volume. Yeah, Harshit, through its reading, yeah, but how do you interpret those readings? Salt water has most mass for same volume. Yeah, the volume is the same in all the three cases. So comparison is easy. More mass will mean more density. Less mass will mean less density. It's mass upon volume. So
change the reading little wrong. Salt water was 240. Sorry.
Or you could have changed their position. Okay, anyway. Yeah, so tap water was 204. Achha, I was reading is at 206. So Nandini is saying when the substance is on the top, it has less density, and if it is at the bottom, it has the most density. You are right. When we float liquids on top of each other, what you are saying is correct. But yes, for liquids, this happens to be the case. See, for liquids, floating and sinking then boils down to simply their density. Liquids, the life is very simple. We put oil on top of water and it floats. So we already saw that in our lava lamp, that oil floats on top of the water. So, oil in any case has less density than water. And actually, it is possible to experimentally see how ordinary water will actually float on top of salt water, but it has to be done very carefully so that the salt water settles down at the bottom and allow the fresh water to float on top.